How did life begin on Earth? The most widely accepted hypothesis is called abiogenesis. Abiogenesis is the idea that life arose from simple organic compounds, which eventually formed more complex molecules, leading to the development of living organisms. Here is a brief outline of some key events and processes that may have contributed to the origin of life on Earth. First, formation of Earth and its conditions. About 4.6 billion years ago, Earth was formed as a hot, molten mass. Over time, it cooled down, allowing the formation of a solid crust and liquid water to exist on its surface. This created an environment conducive to the formation of life. Second, organic molecule synthesis. The early Earth's atmosphere likely contained various gases like methane, ammonia, water vapor, and hydrogen. It is hypothesized that through processes like lightning, volcanic activity, or UV radiation, these simple molecules reacted to form more complex organic molecules. Third, formation of polymers. In the next step, these organic molecules combine to form polymers like proteins and RNA. These complex molecules are essential components of life. Fourth, protocells. It is believed that the first simple cell-like structures, called protocells, formed from aggregates of organic molecules. These structures had a lipid membrane-like boundary, which separated their internal environment from the external one. They allowed the essential biochemical reactions to occur within, leading to the development of metabolism and replication. Fifth, RNA World hypothesis. Another key idea is the RNA World hypothesis, which suggests that RNA molecules were the first to carry genetic information and catalyze chemical reactions. RNA can both store information, like DNA, and catalyze reactions, like proteins. It is possible that early life forms were based on RNA, which eventually evolved to include DNA and proteins as separate components of cells. Sixth, evolution and natural selection. As protocells and early life forms developed more complex and efficient ways to replicate, store genetic information, and metabolize, natural selection began to act on them. This process led to the emergence of diverse life forms and eventually gave rise to the first single-celled organisms, such as bacteria. These hypotheses and models provide a general idea of how life might have begun on Earth.